Although the James Webb Telescope has been in space for less than a year, it has already revolutionized our view of the universe. Set off into the gigantic expanses of space on December 25, 2021, the first Webb images have left both the professional and the interested lay public in awe. Far superior to its scientific predecessor Hubble, the use of the most powerful space telescope of all time is expected to help lift our understanding of the cosmos into unimagined spheres in the foreseeable future. The $10 billion instrument, which was designed specifically for infrared astronomy, will sometimes get a look at the first luminous formations that emerged after the Big Bang and during the so-called Dark Ages. However, some of the data Webb transmitted to the terrestrial research stations also raise big questions. It seems some observations stand in glaring contradiction to the Big Bang theory. Do we have to rethink the birth of our cosmic home completely? Let's take a closer look at this exciting topic together. Want to learn more about the groundbreaking discoveries and fascinating spectacles in the universe on a regular basis? Then remember to subscribe to Simply Space and click on the bell to stay updated from now on. By giving us a thumbs up, you're motivating us and showing that we can keep you engaged with the content of our videos. To understand why some observations of the James Webb Telescope shake the formation theory of the cosmos, we should first take a look at the Big Bang itself. According to the standard cosmological model, the Big Bang refers to the process that led to the unfolding of the universe some 13.8 billion years ago. Although the term Big Bang sounds extremely martial, it does not mean a gigantic explosion into an existing space. It was rather the space itself, which formed together with matter and time from an original singularity. A short classification in the world of astronomy: singularity describes places where the gravitational force is so strong that the curvature of space-time diverges, or, in simple words, is infinite. But how is it at all possible to reconstruct the starting point of the cosmos nowadays? Well, in this respect, the cosmos grants us a natural assistance. As is well known, the universe is not a rigid, unchanging construct, but one that has always been expanding. If we now look at the expansion of the universe backwards, we finally reach a point where the energy and matter density become infinite. The most outstanding evidence for the Big Bang theory is the detection of the cosmic microwave background radiation. After the birth of the cosmos, matter and radiation were initially in thermal equilibrium. In the course of the expansion of the universe, both the temperature and the density of this coupled mixture decreased. About 380,000 years after the Big Bang, temperature values of about 4,941 degrees Fahrenheit allowed electrically neutral hydrogen to form. Since the free electrons and protons involved in this so-called recombination were now missing, radiation could no longer interact with matter, and the cosmos became transparent. The almost isotropic microwave background radiation, which still fills the universe, originates from exactly that epoch. However, exactly how and when the first stars and galaxies in the universe were formed is uncertain, and as we know, the James Webb Telescope is designed to help track down this fundamental question. The bottom line is that the Big Bang theory is considered the leading explanation for the origin of the universe. But does this general acceptance also mean that this common thesis actually corresponds to reality? That experts were sometimes drastically wrong over the course of time already shows a short view of the research past. According to this, the geocentric worldview was once deeply anchored in the minds of our ancestors. In the meantime, of course, we know that the Earth is by no means the center of the universe, around which all other celestial bodies revolve. And also, the Big Bang theory does not seem to be incontestable. In fact, it should be mentioned here that the Big Bang theory is not at all concerned with the Big Bang itself, but describes the early cosmos immediately after its formation. In truth, our present physics is not at all capable of describing the actual Big Bang, let alone the time before it. Among the experts who express their doubts about the current doctrine is Alison Kirkpatrick. The astronomer, who is in the employ of the University of Kansas, regards Webb's latest revelations with great unease. According to her, the discovery of surprisingly small, uniform, and ancient galaxies is inconsistent with the explanations of the Big Bang theory. The Big Bang presupposes that galaxies and other objects in expanding space do not appear smaller with increasing distance, but after a certain point even larger. Now, however, this fact does not seem to be consistent with the initial Webb images. In fact, the images show that the corresponding structures become smaller and smaller, even those gravitationally bound collections of stars that clearly exceed our Milky Way in terms of mass and luminosity. This unexpected fact leads a few scientists to a revolutionary thesis: the universe is not expanding, and redshift is not proportional to distance. Albert Einstein believed in a static universe. To reconcile this assumption with his equations, the physicist introduced the cosmological constant, a move the genius would later discard and call the greatest folly of his life. Although the expansion of the cosmos was demonstrated by Edwin Hubble as early as 1929, to this day, some scientists believe that the notion of an expanding universe is nothing more than a vast fallacy. Eric Lerner and Riccardo Scarpa also proposed this unpopular thesis into the field some time ago. Based on Hubble images, the researchers came to the conclusion that the registered redshifts are consistent with the expectations of a non-expanding cosmos. Therefore, the two experts were confident that the Webb telescope images would also provide further evidence for their beliefs. Advocates of the Big Bang theory had expected in advance that the images would show nearly mangled galaxies, clearly showing signs of mergers and collisions. Reality, however, painted a literally different picture. According to this, the ancient collections of stars present themselves as strikingly uniform structures in the form of disks and spirals, just as is the case with their younger counterparts. In detail, Webb's observations show us 10 times more uniformly shaped ancient galaxies than experts had previously predicted. As is well known, the study of remote galaxies is also always like an optical journey through time. Since the light from these collections of stars sometimes traveled billions of years before it reached our terrestrial eyes, we see the corresponding formations today as they appeared in ages long past. According to the Big Bang theory, the most distant and thus oldest galaxies can be seen on the Webb images as they were about 400 to 500 million years after the formation of the universe. The inexplicable is now, however, the circumstance that some of these formations possess star populations which are apparently more than 1 billion years old. The conclusion which some researchers deduce from this mysterious circumstance is, therefore, since nothing can have originated before the Big Bang, the bare existence of these galaxies proves that the often quoted Big Bang never occurred. In truth, a look at the papers published so far shows that the Big Bang theory is by no means flawless even apart from the Webb recordings. On the contrary, the thesis currently makes 16 incorrect predictions and only one correct one. Accordingly, the Big Bang prediction for the abundance of helium deviates by a factor of 2. The prediction for the abundance of lithium is off by a factor of 20. Only the abundance of deuterium, an isotope of hydrogen, is correct. In addition to the absence of optical effects due to large distances, there are also structures in the universe which, according to our knowledge, are simply too large to have been formed in the time since the Big Bang. Also, wrong predictions for the density of matter in the universe, as well as inexplicable asymmetries in the cosmic microwave background, seem to shake the Big Bang theory in its foundations. In view of all the alleged contradictions that accompany the hypothesis of the origin of the cosmos, one question arises: why does this astronomical crisis receive so little attention in the general media? Well, in this respect, the anti-Big Bang advocates see themselves as victims of the prevailing zeitgeist. This means that all experts who seriously question the Big Bang are labeled as ignorant and inept by the rest of the scientific community. What's more, the corresponding work is often dismissed as heretical, and only in the rarest of cases is it supported with funds. The other camp, however, points out that the Webb recordings are still awaiting full-scale evaluation. It is correct that old galaxies should appear more disrupted than younger stable galaxies due to their stronger interactions in the previous models. However, it must first be determined how old the structures captured on image actually are. Although the first data point to a very high age, a verifiable analysis must still be completed. Accordingly, it is conceivable that some assumptions will be confirmed and others not. What findings await at the end of this research path is therefore currently still written in the stars. Whether the Big Bang will actually be disproved one day remains to be seen. And now we want your opinion. What do you think about the generally accepted Big Bang theory? Do the Webb images provide evidence that the cosmos is not actually expanding? As always, drop us your thoughts, suggestions, and feedback on today's video in the comments below. Are you in the mood for more exciting contributions on the topic of outer space? Then take a look at the other videos on our channel, which you can access by clicking on one of the images in the credits. Thanks for your interest. Take care, and we'll see you next time.